Anyway, since nobody saw what I was talking about 7 minutes ago, and we're going to pretend that never happened, here's the IK stuff that I was talking about. This is a single chain IK. Yeah, everything I said before applies. So the end of the bone chain sits into this big sphere, tries to match that all the time, and we're kind of pulling this bone chain back and forth to, you know, make it be in that position. So the goal is multiple spheres and multiple chains. So like a Y shape is what we're going to work on. Well, can't stream without making some mistakes, right? So, in any case, I also mentioned that there are multiple repos in the project now. This is all currently in a PR on GitHub for anybody who has been following the streams. That's the wrong repo. So we've got this PR up. This has all the code that we've been working on stream. It has the demo, the examples, etc. So that's all available if anybody wants it. The 2D and 3D here, I was talking about a second ago how we have this bone length component. And this bone length component in the examples is used to define how long the bone should be, because the bone lengths aren't supposed to change according to the algorithm. They're supposed to just be static the whole time. So initial implementation, we just hard-coded that. But in the new implementation, we derive that from the initial positions of the bones. So instead of having a bone length component, we don't have that in this example. And instead, we do a local in the Bevy system. So we've got a local here in our system. This runs in post-update. It's a hash map from entities, which are the keys, to a tuple of bone lengths and like all of the individual bone lengths. So the total bone length as an F32 and all of the individual bone lengths as well. Basically, when we start our algorithm, we start iterating over the IK bodies for the end effectors. And we say, if we have one from that hash map, grab it. If we don't, then create and insert it. So this is just scanning along all the bones up to the root, finding all the bone lengths, and then storing them in a vec along with the total length, which is what we get out of here. We then use that in every successive loop, and we zip that with just the entities in general. So we end up with this vec of current positions, and the vec of current positions is what we use for the rest of the algorithm. So this is a vec of all the global positions, all the bone lengths, and all the entities, just in case we need anything. That's the minimal set of data we need for the algorithm. We reverse that to put the root at the beginning, and then we do the full kind of FABRIK implementation. FABRIK implementation, once it's like pulled out into pieces, is pretty small. While the end isn't at the place where we want it to be, or within the tolerance of the place we want it to be, then, or if we've hit the max iterations, then we do a forward pass, which is from end effector to root. We do a backward pass, which is root to end effector. And then we update how far the target is from like our end effector from where we need it to be, or want it to be anyway. And if it's not there yet, then we do it again. And if it is there, then we're good. And then there's this last function that just takes all of the positions, because we end up with basically a vec of all the positions that we're supposed to be in, and we translate that into actual transform hierarchy. So multiple end effectors means a couple of things. It means we can have the concept of sub-bases here, or kind of like places where the IK chains meet, might be a better way to phrase that. The algorithm, as I understand it, is basically take all of the chains that meet up with this subbase and calculate them all for a forward pass. Then pick the centroid of that position, and then do the next chain and pick the centroid of the subbase, and then do the root, and then go back the other way. Basically doing the same thing. For every subchain of bones, we do the whole calculation in both directions. So that's the next step. I think that to me, that means that we need a way of determining for a given, I guess, end effector, which group it's in. Because right now we're doing iterations over every end effector, assuming there's only one chain that it's relevant for. And I think what we actually need to do is change our loop here a little bit. So this IK end effectors, we will end up probably grouping them in some way. So we might end up with like another local here, which is something like, what? This is going to be a bad name, but cached IK chains or something, which is going to be like a local. And this is going to hold, I guess, based on the, I guess we can't really base it on the root. I think one of the things that's interesting about this is the way we have it set up currently is we specify a component on the end effector, and then we specify a number of bones that it can handle or control going upward. But the way that that works out is if you have a bunch of end effectors that meet up at a certain subbase, then that subbase becomes like the root point, right? So we kind of need to build up the IK chain graph, if you will. So I guess let's start with building an example, and we'll go from there. So how do I want to do this? I think I want to do this by copying the long one, which is the one we've been looking at. And effectors. I'm going to rename these examples, but for now, they're just going to be really messy and long. So we end up with this command spawn, which does a bunch of children here. I think what we want is to just fork off at like joint 3. So we've got root, joint 1, joint 2. We could fork off at joint 2. But I still feel like I want to do it at joint 3. So let's do everything from joint 4 down. I feel like I should build a function that can build a bone chain like this out of it at some point, but we'll see. So joint 3 then is going to connect to, I guess, 2 joints, which is interesting. One of the reasons that's interesting in my mind is right now, the subbase is The subbase has a mesh on it. And that subbase is going to point in a position. But if we look at the graphic here, this would theoretically mean that a subbase, if we were going to visualize it with a mesh, would need like up to 4 submeshes, which is really interesting as a concept. They don't really talk about that at all, I don't think. But like theoretically, there's a mesh for each subbase that points in that direction. I think for now, we're just going to get kind of like rid of the mesh that's here and not worry about it. So I'll just comment this out for a moment. And then that means we will have this joint chain and then a joint chain next to it. And I guess I'll just name these like A and B as postfixes. So if we do that, this should break. I don't know how it's going to break, but it's going to break. I guess it doesn't break. I guess it doesn't break, which is really interesting, actually. Because these would be all in the same position. You can see that we've taken out that middle bone. So it's like bone, let's see, root, joint 1, joint 2, joint 3. We've taken out that mesh in between the two. And then we've got 2 more joints on the end. So the IK chain is still here. That's still like a bone, so to speak. But we should be seeing, I guess, 2 of them at some point. So each of these targets is currently pointing at the same target. And we probably need the example to differentiate a little bit. So let's set up 2 sphere targets, I guess. I don't want to rely on like the ordering of a query. So what I'm going to do is I'm going to make 2 sphere target marker components. And we already spawn in a sphere target here. So we will spawn in another sphere target. And this will handle, I guess, both of them in my mind. Although technically it only needs to handle 1 of each. This comes into like a question of API design in some respect. So the inverse kinematic end effector right now holds just a position, which means that we are responsible for updating it. Which means that we are responsible for like determining how to get at this entity and then update it. We could, in the future, if this becomes more of a generalized crate, let this target be like an entity that must have a global transform on it, which may be easier to use, but we don't have any real use case for it right now. So I think what I'm going to do is just like duplicate these components and mark everything explicitly for now. I'm going to call this like sphere target receiver. So sphere target receiver and sphere target B receiver. And that means that we have sphere target B, and then we have an end effector. Which is going to be a single for the mutable inverse kinematic end effector with this marker component. And this is going to be the same thing for the other one. This is kind of a verbose way to do this. I don't know that this would be the way that it would happen in practice, but kind of just setting ourselves up for making this a little bit easy. And then we can always work our way backwards to a better API. Okay, so we've got end effector target equals sphere target dot translation because we've just made that change. And then this also needs to happen for sphere target B. And this is end effector B. And these need to be in different directions. So maybe we will do them. Maybe we'll do them with like an X offset. And then theoretically, this should break. Right now it's breaking because of mutable transform. So we need to differentiate these two. Basically what we're doing here is we're grabbing mutable access to transforms in these queries. So we need to differentiate between which one of those is actually going to be different from the other one. So that we can tell the type system that we are not actually going to be accessing multiple mutable transforms that could be the same transform. And then this one is going to be the receivers. Receivers need to do the same thing. We don't really need to do it this way. This is a little bit verbose. And I think we only really need one of them, if I'm being conflicts. We could also do a param set, but I'm just being a little bit lazy in the interest of getting this to run so that we can get into the example. Okay, and now we have what effectively I would consider kind of like a broken setup, right? So theoretically, this is just broken all the time because we don't have multiple end effector support. So what's happening right now is something along the lines of the IK chain iterations are competing with each other. Actually, the sphere isn't moving either, right? So that's not true entirely. This is sphere target B. We didn't put the first of all, I didn't actually update this to be the correct component, sphere target B receiver. And then the other thing we need to do is specify the end effectors. So I said I was going to label these, and I'm going to now. Then we need to go to our other one, same thing, label it with the other one. I'm still not expecting this to work, but I'm expecting it to actually run at least. So we end up with this like weird kind of thing going on. And I think we got this weird kind of thing going on because this is actually the two IK chains effectively competing with each other. So one of them runs first, one of them runs second, and you can kind of see how that like is affecting the weirdness for the case in which we would have multiple end effectors. Hey, Saurav, how's it going? So this is now effectively broken and requires multiple end effectors, which is what we were looking for. We've got 2 targets. We've got 2 IK chains. Both of them are specified to go to the root. We've got a Y-shaped, like end effector chain situation. So we have a subbase in there, and then we have our root, and we have our end effectors. So back to our IK bodies. If we validate our assumptions first, this is an IK body. And we're seeing that we have 2 chains being operated on, 29 and 34. Good to see you back after a day. Yeah. Okay, so we need some kind of way to build up this like IK graph, so to speak. And I think that for the actual algorithm for future work, we do have to deal with loops. I think I have that paper here. This paper specifically. I think they both talk about it a little bit. If we go further down in this one, I think this talks about it a little bit too. Maybe it doesn't. Maybe I got my papers confused. So this paper is the model constraints extension paper, and it talks a little bit about these loops and what they look like and stuff. So theoretically, we need like a full graph that can get traversed. I think that we might cut this a little bit shorter than that. So the thoughts in my head are basically, we need a tree structure currently. When we move to model constraints, we will probably need something that can handle loops. The tree structure that we use will have entities as the values. So it'll basically be something like IK chain, or I don't know what we're calling this. IK chain, and we'll say what, like children or of something like that, right? Is a vec of entities. And then I guess we also need parent. We don't really need parent because these parents are inherently held. We probably want the bone lengths here. So this is probably our bone lengths cache. So we'll probably store the entity for the current node. Right, this is an IK node, or like a joint node or something like that. We'll call this IK joint node. So we've got the current IK joint node. We've got the children that IK joint node has. The children probably have bone lengths. So let's just create a type alias here. just for documentation purposes. Type aliases are kind of great for this because we get to treat that as an F32 no matter what, but we get to document it in our types when we use them. Hang on, I'm going to check my fan. It's a little bit hot in here. That's why I had it turned off. Dang. Okay, so we've got this IK joint node. This can just be kind of a tree. It's going to be entities and F32s with owned data. So I'm kind of not really concerned about this structure. This also technically allows looping back on itself. So we could theoretically have a loop in this. I think that we'll have to address that when it comes up. And for now, we'll just say, if there's a loop, good luck, have fun. So IK joint node, then we already have a way to calculate all of the bone lengths for every chain. We don't store the entities currently. We could. The tree structure here is a little bit weird. I almost feel like any entity that is involved in a single IK chain, no matter where it is in that IK like graph, all of those are part of the same IK chain. So it almost doesn't matter. Right? If we do a hash map like we have here of entity and bone length, then we can fill out that entire hash map. The thing that I have in my head is that we basically need each of the segments up to a common ancestor. I think we can get that information. It's just a little bit weird. We took some mesh off our subnodes, so we don't really need to care about that at the moment. But we kind of do need to care, like, if there are children, right, in the like child of children sense. If there are children, as we iterate up an IK chain, then if they are bones, then this is a sub node. Do we call them subnodes? I forget what we're calling them. Sub bases. We're calling them sub bases. If children and they are bones, then this is a sub base. So I guess we could go up every chain. I don't know how we tell which one is like the furthest ancestor in that case, though. I'm basically thinking about going from root to chain on all of them, building up that whole hash map. And then I guess we have a set of overlapping overlapping subsequences. But that's not strictly guaranteed. So how do we figure out what the root of the IK chain is? I guess we could label it for now and then go back and fix it later. Actually sounds like the right move. I think that we should have a temporary struct here. IK root, right? So this is a component. It's called IK root. And if an entity has this, then it is an IK root. And we're currently saying that if you touch any chain in an IK root, then you are part of that IK root, and there's only one IK root that can control a given node at a given time, which I think is all good to go. So in our case, this is IK root. And we'll just use this to identify the root for now, and then we'll come back later and do something a little bit fancier to get rid of this IK root label again. But in the meantime, I think that means that we can basically build this IK joint node from top down if we build this hash map from bottom up. So this will be a hash map from a bone entity to length. So we'll change this, right? I guess technically this structure is what we use for subchains. Thinking about how much I want to pre-cache and how much I don't. So theoretically, if we have all of the bones that exist in the world cached like this, right? Every time we have an end effector, we basically need to build this structure. Because if we don't build this structure, then we don't know where the subnodes are, because we need to know. We could label the subnodes too, and then we wouldn't have like an issue. And then come back and deal with this. Is that the right option right now? I don't think so. I'm feeling a little bit like I want something like a vec of vecs. So we end up with like a vec of vec of entities, where like an IK chain is just a vec of entities. All right, so we end up with a vec of IK chains. No, we don't end up with a vec of IK chains. An IK chain is a vec of entities. We want multiple chains. Right, theoretically, we have a vec of IK chains. Do we just build the graph and then iterate and then walk it? Am I just trying to like ad hoc rebuild a graph here? I think the only thing we don't have from the way that we're currently doing things is we have no idea which end effectors are associated with which roots at the current moment. So if we do that first, I think this is going to be a different system to build these structures, and then the process inverse kinematics is going to operate on them, but we'll do it in here for a moment. So this is like the same thing here, right? So for every IK body, we end up with an end effector. We have to iter ancestors. And in this case, I think we iter ancestors until we hit the root. Is that not what we called this? My own capitalization coming back to haunt me. I don't know. IK root, who cares? Why is that an issue? Doesn't matter yet. So query for entities with IK root. Why is that an issue? Hang on, let me run this. Oh, because it's one tuple. That's why. It's not supposed to be a tuple. Okay, so we've got all of the roots and we've got all of the end effectors. And I think we don't do this nth for now. And we just do like find entity root query dot get entity, right? I guess we can find map this. Doesn't really matter, they're the same entity. So if let's sum IK root entity, then found root, and this is going to be end effector entity and IK root entity. So what we should end up with is both of our current chains should hit that. And then we'll include a error here. And the error will be no IK root for end effector entity. Root query here should work. What's the problem with that? Yes, expected entity found entity. And then there was another one that oh, this is the result. So this is dot okay. So we don't actually care about the error. And I guess we can find map this and we get to use that. And then find map means that it wants a reference instead of a entity. Cool. So now there's all these other things that are going wrong down here, but that's fine. I think we have all this logic. This is inside of the loop. We have all this logic, but I've effectively broken it more or less. So let's just comment it out for the moment. And start with our smaller case. This needs to come into scope for my increasingly long lib.rs name, pub struct ik root. Why is that an issue? Oh, right, because ik root. Okay, so we end up with the chain, right? And we have the visual here is supposed to look broken, just as a pointer. So we've got entity 34, root entity 18, entity 29, root entity 18. So now we have the end effectors and their associated root entities, which is good, because that means that if we go down from the IK root through all of the entities that we've discovered through doing this, then we will have the chain from root to tip. So maybe doing a little bit of extra work here in terms of the traversal. But not too concerned about it. And just trying to get to the point at which we are implementing more stuff. Can always come back and refactor. So iter ancestors, every ancestor we hit is going to be a valid entity. So is this a fold? Fold into a hash set, maybe? Right, we need to find a valid ancestor for this to work. If we never find an ancestor, this can't pass. Unfortunately, we've already done the traversal work by the time we know whether we've succeeded or not. So I think it is a fold. We can't early terminate a fold though. So if we do find the root, that would force us to go up all the ancestors. So I think this becomes just like a regular for loop at the current moment. We could scan it and produce the entities, but we don't really have a reason to like retain state. The only reason for writing a scan here would be to produce that none at the end. Right, because we could do scan false because we haven't found it yet. state, which we're not really going to use, and whatever else. Next, right? And then we like return next every time, which can just be, some next, because this is just going to be an entity. And then this can be the test here, right? I guess this could be none and some, and then we could just do state equals this. What is the wrong with that? Oh, this will just be entity, I guess. So theoretically, if we scan this like that, then we can just collect. And collecting this into a vec of entities is fine. But really what I want is a hash set of entities. Set capital S. I guess technically we have Bevy collections, right? These are the same collections. There's just a slight difference. Right, so we've grabbed that hash set. And we should be able to collect into this hash set. What is the problem with the hash set? The hash set is probably the fact that I didn't capitalize the S at the moment. So this presents us with, I guess, the same problem in the sense that like producing this will always loop over. So let's do for entity in parents that are ancestors, let discovered entities equal hash set entity new, right? Turbofish. If you weren't using Rust's format, how would you format your code, including tabs versus expand tab and number of spaces per tab? I personally probably wouldn't use a language without an auto formatter. Not having an auto formatter is just such a waste of time. That said, if I were going to engage in trying to build some kind of auto formatter, I would probably prioritize tabs over spaces for accessibility reasons. But most implementations that I'm familiar with don't do that, and you end up with a bunch of spaces. I don't personally have those accessibility concerns, so it doesn't bother me a whole lot. But if I were going to implement something that did auto formatting and I was writing, a language or whatever, and I had to make the choice between tabs and spaces, I think I would choose tabs for accessibility reasons. But I don't think I would use a language without an auto formatter. It's one of the reasons that I think that BSN probably needs to ship with an auto formatter. Like I'll use BSN when it comes out regardless, but Not having an auto formatter would be a huge fame. C doesn't have an auto formatter. Is that what you're saying? I mean, I don't write C, so. Yada yada. For entity in parents or ancestors. And we'll have our stop condition. Bound root. This has to be mutable. This also has to be mutable in this instance. Not included in the language itself. I mean, like, a secondary auto formatter would also be fine, as long as there is an auto formatter. I do think that having one built into the language is the best choice. Languages like Go and Rust that have that, I heavily prefer that over any other solution, but secondary auto formatters like Prettier in the JavaScript ecosystem are also useful. I think, to me personally, the syntax of a language that I'm writing is secondary to the semantics that I'm trying to convey. You wish Rust had some options for formatting, like compact or attributes to set styling for a block. I mean, there are options. If you do, what is it? Rust format print config default rust format.toml. This thing on screen right now. Just realized that's probably way too small for anybody to actually see. We haven't been doing any terminal work, so whatever. But this Rust format print config default Rust format.toml, there's your options. I heavily customize this for things like blog posts. It bugs me when blog posts have like long horizontal scrolling for code blocks, because that just seems like such a waste, right? Like needing to, like if I'm on my phone and I need to like do this repeatedly to read a code block in a blog post or something, it just, I don't know. It's something that I care about. So you'll see, like when I have my stuff formatted here, the way that I format things typically is not the way that you see most things formatted. Because I have a root cargo toml or cargo, sorry, not cargo. I have a root Rust format that keeps things very small, that wraps comments, sets my comment width to something pretty short, sets the function call width to something pretty short, etc. So when I write code, typically, unless there's a reason for it to be long, in which case you can always print the default config and throw it into the folder. Right? Which is what I have here. But you'll see in a lot of these other examples, they're much more vertical, a little bit smaller than you might see in other places. And that's because I care a lot about, for example, showing them at an appropriate size in a video, or showing them at a reasonable size in a blog post, or anywhere else that I'm putting them. So there are options. I just, generally speaking, prefer to not have formatting conversations. I think that formatting conversations are not... I know that people care a lot about them in general, but like, they're just not useful conversations in general. I think if you're building an auto formatting tool and have to make choices, then cool, talk about it. But like, if you're like, oh, I like to write my curly braces on this line rather than this line, I don't really care. If it doesn't bother me either way. The only thing that I really care about is having it automatically handled for me, and once it's automatically handled, I really don't care. This is a warning about not using the root, right? Forward, backward, bone length, current position, discovered. Mute, bunch of stuff we're no longer using because we commented stuff out. Global transform, gizmos, found root. Yes, that's because we're not using it. Okay. Okay, so right, if found root is some, then I don't know, do something with discovered entities. Do you set up your files to auto format on close? I don't know what auto format on close is. They auto format whenever I save. So if I hit enter here and I hit save, it'll auto format. Which honestly, auto formatting is one of the ways that I know that I got my syntax correctly. And I have a habit of doing things like, oh, that's not what I wanted to do. I have a habit of doing things like this and writing code way over here and then hitting save and it auto formats. Okay, so this is not the best way to build this vec. I am not concerned about that at the moment. Insert for hash maps or hash sets. So discovered entities for this IK chain, found root, yes or no. If we find the root, then I guess we have some kind of we could be building up the bone lengths here. I think that the case of bone lengths is interesting, I think, because these subbases have 4 bones coming off them. So right now, all of our bones are from root to next node, and they're on root effectively. So really, we're kind of generalizing to a bone is just the distance between 2 nodes, even more than we were before. Which is interesting. What about auto format on type, though? You mean like press a character and it auto formats? I think that results in a bunch of garbage code, doesn't it? I think you're joking, but just you say as long as it's not a repository that you want to commit to. I'm not sure what that's in reference to. You read up a bit. If you weren't using Rust format, you would try to format it approximately the same. I don't see any reason to diverge from established practice. Yeah. I think that going with the kind of like dominant community formatting makes a lot of sense. That's one of the reasons that I never really got into like no semicolon JavaScript. But at the end of the day, I just don't care. Like, the reason I'm programming is not to have like a pretty array of brackets. FABRIK is so simple for IK. What are some issues with multiple effectors? I think all of the issues with multiple effectors are just me building the structure right now. Um, the algorithm for FABRIK for multiple end effectors is effectively just break it down into a bunch of separate chains, work your way in from the end effectors to the subnodes, subnode to subnode, subnode to root, and treat all of those as kind of like individual steps, if you will. So in this example here on the right, there are 1, 2, 3, 4, 5, 6 chains that go to 2 subnodes. So for these 2 on the right, you would do both of them before this subnode, and both of all 4 of these, you would do all 4 of those before this subnode. And then the next chain would be this subnode to the kind of like middle subnode here, and this subnode to this subnode. When you're doing the subnodes at that time, after you've done, say, the 4 on the left or the 2 on the right, you end up with 4 points that this subnode could be in, which means you have to pick the centroid of 4 points. On the right-hand side, it's the centroid of 2, which is significantly easier, and so on and so forth. And then once you get down to the root, you just do the backwards pass the same way that you would normally do it. And that's the algorithm. So it's not that much different. The difference is basically like the way we've chosen to specify the end effectors is to put a component on each of the end effectors. I think this is okay. I didn't really love it when it was suggested. But it's reasonable as an approach. And I've seen some other IK libraries that do it at this point. So the way we have our end effectors specified is we pick all these edge nodes, which there's 6 of them here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Like a number that is called like affected bones, and that number is 9, right? To get back to the root. It doesn't inherently matter that they are all 9. So like this one could be 6 and it would get to like this node here. And it would still be considered part of that chain. And I think that's what I'm trying to build up here. Basically like the idea that not all of the IK chains need to specify the affected bones completely to absolve into the same root. If we did have that restriction in that all IK chains needed to specify the number to the root, then we could just iterate up all the end effectors, find their root node, and then say they're all part of that root node. But yeah. Basically building this tree structure is kind of the thing in my head right now. More than the algorithm itself. And I know, so I'm doing the thing where I think ahead again, that I was doing on like, I think the first stream where we were talking about what would this look like in GLTF? The model constraints paper for extending FABRIK has loops. So in my head also is if I choose something now that doesn't work with loops, then I'm kind of choosing something wrong for later. Yeah, basically building up these trees is where we're at the moment. So for every end effector, if we go to find the root, then cool. Otherwise, we need to find, I think I'll leave a note here. If we don't find root, find a an IK chain with at least one entity. So this is where it comes in, where like, should we just be doing pet graph here? Like, should we just be throwing this into an actual like graph library? I don't really think that we need like a full graph library. And the iteration that we're doing is so simple. But building this up, we're going to make some assumptions to get through this. We're going to make the assumption that all of the IK end effector chains connect to the root. And if they connect to the same root, then we'll put them in the same bucket. And then I'll come back and I will rewrite this. I think it gets easier if you know everything ahead of time, right? If we labeled the IK root, if we labeled the subnodes, and we labeled the end effectors, then we could go end effector to subnode, subnode to subnode, and just kind of store those positions. And that may be a better way of doing it in the longer term, but we'll see. Actually, now that I think about it, if we go... No, because we kind of have to identify the subnodes first, is really what we have to do here. We have to identify shared nodes in a graph. Which for us, for the moment, is a tree, but in the future could be like a triangle where all three like bone joint vertices of that triangle are all like connected in some way to other chains. Right? Like you could imagine a root node, a chain to one end of the triangle, and then that triangle being connected in a loop, and the two ends going off into finding their own end effector targets. So yeah, I think it's just like, if you don't know the structure ahead of time, then you have to build the structure. So we're gonna cut this a little bit and assume that all of our end effectors reach the same root node, and then we're going to iterate back down from the root node to find, I think, all the bone distances. And the bone distances now are not singular node values, which is interesting. The bone distances are like between two nodes. Because if we consider the subbase case here, where this has 4 bones coming out of it, then what? We have a transform for that node, and then we have 4 children of that transform, which all have their individual bone lengths. You've got a question regarding implementing an algorithm using a research paper. When does the researcher decide that the research should be patented, and if the paper is part of a patent, can it be used? There's a whole bunch of patent stuff. I think that a lot of the papers that like would show up on this channel are papers that like are free to implement. There are algorithms that people have made and tried to like put patent restrictions on. I think that XPBD is one of them. XPBD patent. So this is kind of exactly what you're talking about, right? This is the grayest area too. This is the indeterminate, like somebody has a patent, but there's also stuff that you can use to implement it. And NVIDIA, I think, owns the patent. So Avian used to be XPBD. It moved away from XPBD for these reasons. NVIDIA owns the patent. This is a link to the US Patent Office. So patents are like per country even. Like patents in the US don't necessarily hold sway in China or somewhere else. But in this case, this is a US patent. And this is, you know, relevant. I happen to be in the US, so it's directly relevant to me, but, you know, maybe it's not relevant to other people. NVIDIA has not used the patent to do anything for people who have implemented XPBD, but they do technically own the patent, and they could if they wanted to. So this isn't the only reason Avian moved away from XPBD. But it is a thing. Right? Like if there's a patent on it and a company owns the patent, that company is allowed to do whatever they need to do with that patent, which means that you need to be aware of whatever you're working on, whatever you're using. FABRIK, as far as I know, is not. So we're good. What are the consequences? That really, really depends on who you piss off. That can be anything from absolutely nothing. You know, there are people who do reverse engineering and emulator work that don't get sued. And then there's the other end of it, which is Pal World, who is currently fighting Nintendo over patents. So it really depends on who you piss off, how successful you are, who woke up on the wrong side of the bed today. But by using something that is patented, you are putting yourself at risk in that way. I think in general, if you're doing something like on your local laptop, and you have no commercial interest and no intention to use anything that you learn in commercial projects, and it only ever stays on your computer and there's a bunch of other qualifications on that, then nobody's going to come after you, right? Like nobody's going to like grab your laptop out from under you in your apartment. If you're just working alone and nobody knows what you're doing. And but if you take that and then like make a commercial product out of it, there's a patent on it, right? If you take that knowledge and you use it to build something, there's a patent on it. So you got to be aware of all that stuff. Nobody's going to know is not a successful legal defense. I'm not a lawyer. Don't take loyal advice from me, but I didn't know is not a successful legal defense. Okay, so in this case, for our example, we currently only have one IK chain. In one of our examples, we do have two. I would like to support multiple. It is easier if we don't. All these other things. Having a hard time getting my brain started today, if I'm being honest. Okay, for entity and iter ancestors, end effector entity, discovered entities, insert entity, found root. So this is all the discovered entities for this particular end effector. If we found a root, then this is associated with that root. This can be a local IK root collections, right? Where this is a local, that is a hash map from entity, which is the root entity, to hash set of entities. Right, and we'll just specify, I'm doing a couple of different type aliases here just to make things clearer for myself. Type aliases do not affect the way that you use things. So they are literally just like aliases that disappear. Root entity here is literally just an entity. I can use it in the type signature here, but it will literally just be an entity. You can use any entity that you have here. But it makes it a little bit clearer about what the intent of that entity is. Otherwise, I end up just having like entity, 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 entity. And you're like, which one is which? So it's a little bit of documentation. So if we found the root, then IK root collections dot entry root entity, right? This is root entity. No, this is found root. So we'll do if let some root entity equals found root, then we will get the entry for that. We do an or insert our hash set. If it's the first time, intersection discovered entities. I think intersection is non-mutating. Let's see, intersection. I guess we could just insert. Or is there like an extend on hash set? Contains difference entry, getter insert. Insert value T. That's individual entities. Replace, preserve, retain, take, union. Intersection is not what I want. I want to append to this. All the values in self or other without duplicates. Union is what we want. And union is a reserved keyword, so we need to specify that with our hash and then set equals this, right? I guess we need to collect this then, right? This is an iterator. So the options are, I wish there was a better way to just like give it another hash set. Am I missing something here? Extend, there we go. I think extend is what we want. Okay, so hash set entity, discovered entities, or insert discovered entities. I guess we could do or insert hash set new, and then just leave it to the modify. Into iter. What's the problem with end modify here? Right, because or insert gives us back the actual thing. So let collection equals this, and then we do collection.extend, right? And then IK collections needs to be mutable. So we end up with a root. We get either the collection that already exists or a new one, and then we extend that with the entities that we've discovered. So we should, at the end of this loop, have all of the entities, right? So let's debug IK root collections. And this should give us, I think, a single chain of a bunch of entities. And this is root 18 is 1, 2, 3, 4, 5, 6, 7, 8 in the chain. How many actually do we have? We have 1, 2, 3, 4, and then we split, right? 5, 6, 7, 8. I think we need 2 more. I think we're missing 2. I think we're missing the ends. Why are we missing the ends? Because iter ancestors doesn't include the end effector. So we need to do our little standard iter once. End effector entity.chain this. I really don't like doing this. This is because we don't have iter ancestors with self. We have to do standard iter once chain on the front of everything. I'm hoping to get around to suggesting an iter ancestors with self kind of function, but it's fine for now. This should end up with 10 then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So that's all the entities. It is not all the entities like in a sorted order. It is just all of the entities. We happen to have, I think, up to like up to 20 here probably is one chain. Then up to 34 is the other chain. And then this is the rest of the root, but we don't know that yet. So once we get everything and it's in these IK root collections, then basically we can say if can we? This is keyed by the root, which is awkward. I think we'll just do this every frame for now, and we'll leave the optimization for later. It's always a good choice. So we have our root collections keyed by the root, and I think this next loop needs to be our same loop, roughly. but it needs to be not on the end effectors, but on the root entities. So for IK root collections, right? For chain, I guess this is root entities. In IK root collections, this gives us every IK chain. Total chain, all entities. So including the fork. Given this, we want to do, I think, some discovery. But I think we might be able to do that as we iterate. So if we iterate down from root, right? If we have all of these entities. If we iterate from root and we check the children and there's one child, right? Then we have a chain of one child. If we check that root and it has two children that are in the set, then we know we have a subnode, and we know that everything up until that point has to be like a chain that we deal with. And I think doing that all the way down the chain ends us with what we want. So let's do, this is going to be like just a lot of looping, I think. And I'm just going to deal with it and we'll optimize it later. So if we have the root, then we'll call this subchains, I guess. And this will start with what current chain. This is going to be like a recursive algorithm, right? So that's fun. Current chain equals vec root. Root.iter descendants. Root.iter descendants doesn't work for us though, does it? Does it? This is going to build everything up at the same time. I think we have to do our own iteration here. We don't have more complicated or more advanced recursion schemes. So we don't get to do things that we might want to. And I think we have to just manually do it. I'm trying to think of how to do the cutoff is really what I'm thinking of. So the recursion itself is easy in the sense that we can get children, we can check children, we can fork off and build up those chains. The problem is we have to build up this structure that we were talking about earlier, I think. I think we're building this right now. So we'll want bone length here too, but I don't know that we'll deal with that immediately. So instead of maybe subchains, let's set this to be IK joint node. And this is We have no idea how many children are going to be here, so we really can't even build this yet. But children is going to be that vec, right? Entity and bone length. There's a reference to an entity. Can we just dereference this? I think they implement copy, right? So if we've got an IK joint node and we need to fill out the children for that node, I've really, you know, every time I think about this, I get closer and closer to I should have just used PetGraph because it already does everything that we need it to do. Okay, so iter descendants, then, right? Not iter descendants because we need children. So let's do we have a query for children? We don't have a query for children. Query for children. Children dot, you would cache the tree structure as it shouldn't change unless a new entity is added or removed, right? Correct. Yes. Yes. And in fact, currently the way that we're doing it in the other examples is well, I think I actually broke it because I removed it. But the thing that we replaced with IK root collections, there's a function in here that I pushed to GitHub actually that I can probably look at. Come on, GitHub. Okay. lib.rs for the, that's the 3D one. That's not the one I wanted. End effectors, lib.rs. So when we look at the process inverse kinematics function, which is the one that we're currently working on, it has this bone lengths local. So this is local to the system. It is kind of like system local data. In this case, what we've done is build up a hash map from entity to total bone length and the vec of bone lengths. And this is the equivalent of what we are going to do with this tree. Because what we do here is we take that bone lengths and we either set it if it hasn't been set for the current entity, or we process it. So this is using the cached version that it got from the local. And up here is doing the insertion for the first time, which is guarded by dot entry on that hash map. So this closure only gets evaluated if there is no entry. And then otherwise we just continue and we get, you know, the vec of current positions by zipping the bone lengths with the positions that they're currently at. So yes, that's the idea. Currently I'm just letting it run. So this is just going to happen every time, but we're going to go back and we're basically going to put that into the cache in the same way. I'm having a little bit of trouble getting started today, so I'm just trying to make things a little bit simpler for myself. So IK chain, root entities, IK collections, .iter, root node is IK joint node. We have this recursive data structure that we want to build up. We could just build up vecs of entities. So my original thought was maybe a vec where each vec is a chain at the same kind of like level-ish. So this is like the root chain. And then this would be the, I don't know, left chain, right chain. And then we end up with like LL chain, LR chain, like that kind of thing. Dot, dot. This was my first thought. This was my first thought because it builds up all of the chain subsegments. And it allows us to have a vec of entities that are the chains that we can then just go down to the last one, reverse them, and then work our way back up. And to build that, we end up building a recursive algorithm and stopping if it has children that are of length 2, and then kicking off new things. So we end up like collecting these repeatedly. I think that'll work. Let me keep this as a visualization. We don't necessarily need to do the IK joint node situation. I think that if we have the root and all of the entities, then we have some sub function here that is basically should I have named that children? Next entities, children get root dot filter entity, and we filter based on if they are in the hash set. So we've got an iterator of all of the entities that are in the hash set currently. We have to kind of know if there are multiple or not to know if we're going to have to stop. So I'm just going to collect here, even though that isn't necessarily the most efficient thing to do. I guess we need to handle the case in which there are no children, which is the last node, which will happen. This will be like, let some kiddos, I don't know. I'm losing my mind. Let some kiddos equals else, I guess, return, which is going to be like end iteration and close vec, right? And otherwise we have kiddos, which is whatever. Hello again, Pasta. How are you? Sorry, you came in late. What is the high-end goal of what you're working on? We're working on 3D inverse kinematics at the moment. The high-level goal is that I want to be able to take something from GLTF, which is like a turret or a spider or something like that, bring it into Bevy, and then run inverse kinematics on the legs and potentially the body as well. We have already implemented 2D and 3D FABRIK. So if I run this with not the example that I'm currently working on, but the, let's do the long 3D one. We have inverse kinematics working in 3D, in 2D, with rotations, with everything, forward, backward passes, the whole shebang is all working, which is great. The thing we're currently working on, the next step, is multiple end effectors. So it's basically the same algorithm, but we have to build up this tree of sub IK chains effectively, and then iterate over them from the end to the root and back in order. So what I'm doing right now is just building up this structure, and from After we have the structure, we can iterate over all the end chains. We get to a sub base, we pick the centroid, we continue down to the root, and then we go back out to the end effectors, and that should work. It should just work because we've already written the FABRIK code. We've written the way to translate positions into rotations and etc. So yeah. So right now, all I'm doing is building up. I'm effectively building up a graph and questioning why I didn't just go with pet graph originally. Anyway, my brain like half turned on this morning. Going good, cooking food, fixing a bug in your code, and playing with some Rust macros, solving that bug. Nice. So right now what we've done is we have gone from all of the end effectors up to the roots and stuck those into hash sets. So now we have the root IK entity and all of the entities that are involved in the chain. And we're going back down from the root to the edges to build these subchains up. So this is really going to be like FN, I don't know, build subchains. And this is going to take, so we're not going to deal with loops at the moment. We do have to deal with loops in the next stage. Right. We have to have the children query here. We have to have the entities as a hash set of entities. And the root is an entity. An entity and an entity. And this is a query for children. So we can run like build subchains here with the root, children, and entities, right? And this is going to be like a recursive. So in layman's terms, does that basically auto discover a 3D object and map a bone structure to it so it can be moved around in Bevy? Yes and no. The idea of a bone kind of doesn't exist. So a bone is really just the distance between two joints. I think this is always true effectively. So even when you're working with an armature and you're building bones inside of like Blender, what you're really ending up with is like two joints, the distance between them, and maybe like the angle that it was initially set to. Which means that we are effectively like building an armature here that is a set of those joints. We are calculating the distance between them to figure out what the bones are. And then we are using those transforms and those bone lengths. The bone lengths are static to do the whole algorithm. Yeah. I think that's one of the things that was, when I started, was most confusing about bones, is that everyone talks about like armatures and bones and control rigs and all these other things, and bones just like don't exist. Everything that we have is basically just a transform and a rotation and a length. And that length is defined by the length to the next joint. So there's no like struct called a bone. There's no like bone specific data. It's really funny, actually. This is okay because this is... So theoretically, we're building up a vec here of some kind if we're building these subchains, right? And really, inside of this, we loop until the entity has multiple children and then return that subchain. So bone is kind of like a high level concept to grasp / work with splines ish. Um, yeah, I guess. I mean, bones like, let's just look at this in Blender for a second. This is a script that I was writing, but if we have like this and we add an armature, if I can remember where armature is, there's armature. And I move maybe this cube off to the side so we can actually see, or we do the, like, you know, the classic thing and delete the cube. We end up with like, quote unquote, a bone here, right? But like, what is this bone actually? Right? There's kind of like nothing here. Um, you have two joints and you have the distance between them. And technically speaking, you're not going to be able to see it here because this joint is a sphere, which is kind of the point. But if you like rotate this on the Z axis or whatever, or rotate this in some way, the joints are transforms in Bevy. Right. So this joint is a transform, this joint is a transform, and you get the distance between them effectively. So if we add more bones, if I can remember the shortcut for adding a bone, like we're just adding another transform on the end. So now we have transform, 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 and two bones between them. But if you look at the data that is the bone, it's comprised of a rotation on this sphere and the distance between the two joints. So this bone, like this middle piece, like doesn't really exist. It's just a visualization. So when we look at this graph, right, we're talking about all of these little circles and all the lines between them. The circles are the joints and the lines are the bones. Yeah, that makes sense. Sweet. That's good because I'm writing an inverse kinematics post and I would love to include a good explanation. Yeah, to be clear, a bone has nothing to do with splines in this context. We're talking about inverse kinematics. IK is how, which is how models are animated. It's one way that models are animated. But yeah, bone, like in the context of a spline or like a curve or something like that, though attributes that you would associate with moving a bone are modulating a transform, right? Like you can have a curve that changes the position of a transform or changes the rotation of that transform, and thus the bone will point in a different direction. Yeah. If kiddos... I guess we loop at this point. This is going to be some kind of loop. I don't know what kind of loop this is going to be, but it's going to be a loop. Because we are going to have kiddos as children here. Children has length. If length is 1, then we only have one thing to add to the current vec that we're kind of building up here. Right? So we get like let vec. Let chain equals vec, where a chain starts at some root and has some children. Yeah, if you have a humanoid character model, then the bones can match the approximate IRL bones relatively closely. Yep. But you also might have bones for allowing clothes to drape, hair strands to move, etc. Things about a model that are supposed to be able to move might have a bone. Yep. Anything that you want to be able to control in a simpler way can have a bone. So rotation for a turret, legs for a spider, human arms and legs, fingers, neck rotations, anything really. Will Bevy be able to be used for robotic simulations in the future? I think it currently is used for robotic simulations. I think there are people that are doing, yeah, it already can. You've seen some neat robotics showcases. Yes. Yeah. There have been a couple of robotics showcases, both simulation side. I think there's actually a crate that will bring in like a specific robotics file format and let you display those inside of Blender. Sorry, Bevy, not Blender. Both of them starting with a B really trips me up. But yeah, it already can. So this at least has to return a vec of entities, right? And theoretically, this would be a vec of entities, where it could be a single vec. Thinking about the recursion aspect of it currently. You thought it's still in beta? You think Bevy is still in beta? I don't think Bevy has got a beta label on it. I think Bevy has a currently under development, so don't expect like a stable 1.0, I guess. I think that there's I have opinions on that. Maybe we won't get into that. I think that I don't know that this makes sense. I think that if we have a discussion about like software versioning, 1.0 is effectively a marketing event, and it's Bevy and the foundation and the community saying, hey, come use Bevy. I think that's what 1.0 is. 1.0 in major versions in any software release are not actually tied to stability, right? Stability is only achieved through stagnation in that sense, right? If you look at, for example, Blender does a bunch of releases. You would think that like version 3 is stable or something, right? But version 3 is out of support. Version 3 is no longer supported, right? So like, can you call 3.6, which was at one point a long-term like service release? Can you even call that stable? Because it's no longer supported. So I think when people are like, oh, 1.0 is going to be like the stable release, that is indicating that those people don't have an understanding of how software works. Because 1.0 or 3.0 or, you know, LTS don't mean stability, except for the fact that they bug fix and that's about it. Right? I don't, there's a list here somewhere of the LTSs and whether they are supported or not. Yeah. So 3.6 stopped being supported in June 2025 for Blender, right? Which means that either you have the opinion that 3.6 is perfectly stable, but then what do you consider 4 then, right? I think that the discussion around 1.0, when it's framed around, oh, when will software be stable, is a indication that the person speaking doesn't understand what a 1.0 actually is. There are some cases where it does mean that, right? If somebody builds a crate that is very small and concise and it's intended to never change again, that can hit a 1.0 and be 1.0 for a very long time. But typically for most applications, for most big projects, for most pieces of software that you end up using as a consumer, you end up with big numbers or marketing releases. The only stability that you get is from it not changing. So you either get an LTS that gets some bug fixes like critical security support issues and stuff, but no new features, or you get new features. Those are your two options. If you want new features, you cannot have stability. If you want stability, you don't get new features. There are people who ship games in like Unity and Godot and you know, Unreal, and I think Rocket League is still on Unreal 4, maybe 3. They might have done yeah, is Unreal Engine 5 scrapped for Rocket League? I think like doing major version updates is a huge effort. You do think you're overlooking semantic versioning in this? I don't think I am, actually. I don't think I am overlooking Semver, because at its core, these 1.0, 3.6 LTS releases are human-to-human communication about what is intended with that release. And Semver is the same thing, actually. It is trying to have a human-to-human communication that is generally understood, that you can rely on this to change in certain ways. And in practice, that actually doesn't happen, right? For example, Rand recently. Big community disruptive change, not in a particularly major version. They are not the only project to do that. These are human communication methods, and they break down in human environments, right? Semver is great, right? I love the fact that we have Semver, that there's some generally agreed upon conception of, you know, what version should be able to break you. But there are a couple of additions to that mean that Semver is not perfect in any way, right? If you have enough users, you cannot make any changes, right? Every change will break some user, given enough users. So Semver breaks down in that situation. There is a whole like, yeah, you can extend the API in minor versions, but you can't deprecate things in minor versions. But what happens, or what just happened recently? Something just happened recently where they deprecated something related to no standard Bevy. Deprecate. Maybe there's an issue about it currently. Yeah, heapless. Heapless deprecated npmc, and they did so in, I believe, a minor version. Yeah. So deprecation minor version. If we're talking about Semver, why did this happen? I caveat that I don't have the full understanding. I looked into it a little bit, but I didn't read up on the details of the implementation. But the TLDR is basically, it didn't do what they thought it did in certain situations. So they deprecated it, which is totally valid, because it's kind of like, okay, so this doesn't do what we thought it did. People need to know about that. How do you tell people about that? And Bevy runs a additional CI pass that is basically like block the build if there's a deprecation warning. So whether you choose to break your build on a deprecation warning or not, which to be clear, Bevy is not doing. Bevy is running an additional CI pass just as like a future heads up, more than a actual blocking breakage. But if you choose to opt into things like warnings, then anything can break your build. If you don't, then it doesn't. You tell people about that using advisories ideally. All I'm saying is that Semver is the purpose of Semver is not to be a perfect spec that is implemented. The purpose of Semver is to have like a reasonable generalized understanding between two humans about what is expected, not what actually happens in practice. Have you ever developed a complete game using Bevy? I guess it depends on what you mean by complete. I've built a bunch of games that are like finished and playable, but nothing that I would consider like Steam releasable. Most of the games that I've built are smaller games, things like, you know, Tetris or Snake or Minesweeper or Flappy Bird or small demos and experiments and things like that, et cetera, et cetera. I haven't built something that I've released on Steam. That is a goal. Right now, what I'm doing, actually, the IK stuff that we're doing right now is for a Scheme demo. So not to go off on another tangent. But Scheme is a Bevy and Blender integration where you can insert components onto stuff inside of Blender, and then you get those components instantiated inside of Bevy. One of the things that people want when looking at Scheme is a full game. They want to see what a full game looks like. So there's a couple of things that I'm working on towards that effort, which include material layering, IK chains for like spiders and turrets. You need like a character controller. I don't think so. I'm roughly basing the implementation on Tunic. If you've ever played Tunic or you haven't played Tunic, it's like this little fox that runs around. I think is a good example, and it fits kind of the skill set of most people who would be looking to use Scheme. I've done like the foliage, the grass and stuff. I've implemented most of the material layering that you see here. I've implemented now IK for the spiders and stuff. And then once that's all done, it's just about putting it all together and shipping that demo. While you're right in that Semver is often broken quite casually, that's not the intention of Semver itself. Semver is a specification about version numbers and compatibility. There's a whole spec here. There's a bunch of rules. Different ecosystems even deal with this differently. For example, they have a suggestion about 1.0, and their 1.0 suggestion: if your software is being used in production. That's what a 1.0 is. if your software is being used in production. That has nothing to do with stability. Right? They're saying that you should have a stable API or whatever. But like you look at software like WGPU, should WGPU be 1.0 because everybody's using it in production? I mean, I guess they changed their release numbers, right? So docs.rs WGPU is now version 27 instead of 0.27. So that kind of reflects that, but that's kind of what I'm getting at. Like this is yes, there's a spec here, but it relies on human to human communication and what's generally agreed upon. And the spec helps with that, but is not perfect. You need to control Valve to be able to release on Steam. No, you need to pay them $100. You don't. The only thing you need to do to release on Steam is pay Valve $100. There's almost literally nothing else that you need to do at this point. Obviously, your thing can't be like complete malware. I think they do a review on it, but literally, it's like pay Valve $100 and you get a Steam page. Lon is saying, in non-OSS area, there may well be contracts which rely on Semver for various terms. The fact that it's being broken is a community issue, not a flaw in intended mechanic of Semver. I would argue that if Semver is being broken by effectively everybody, then that is the usage of Semver in practice, right? We can't have a discussion about Semver and only talk about like what happens in an idealized, perfect situation. We have to talk about what happens in practice, and in practice, it is a loose human-to-human contract. Can you give a few advantages of using Bevy over Godot? I think if you're going to do something like a game that requires kind of really intense customization, something like TinyGlade, or something that requires a lot of heavy data processing. The ECS is really good at like churning through a whole bunch of co-located memory. TinyGlade is a great example because while they don't use all of Bevy, one of the strengths of Bevy is being able to replace pieces of it. They replaced the renderer to great effect, which is something that's really hard to do in other ecosystems. That kind of stuff is what I would say that Bevy is best at currently. The kind of like weird edge, like people who are more advanced users who know how to program, who have opinions about how things should be, want to drop maybe certain pieces of Bevy, and are comfortable implementing things, and maybe need more performance that they can get from other engines. I think that if you're going to do something that is like yet another 2D platformer, and your main differentiation for that game is going to be the art style, Bevy is comparatively weak on creative tooling and creative tooling support. So if you're going to do something that is like generic 2D platformer, but the art carries the game, you might want to do that in Godot or something like that. Zero-ver is your main versioning approach. Does that mean your software never gets released? You never said 1.0 had anything to do with stability. I'm saying Semver major versions and projects that fully follow Semver have a very strong guarantee. Nobody fully follows Semver. Unintended is Valve and Steam. You fully agree that software versions are often used loosely, but that's separate from Semver. It's a spec. The spec itself is written very clearly. I disagree with you on that. If the spec is written so clearly, why does one ecosystem start at 1.0 which is npm in JavaScript, and why does one ecosystem start at 0.01, like Rust? If Semver is so specific and so clear, why is there major ecosystem split in the implementation? What do I think about Flax ECS library for C? I assume you mean Flex. Flex by Sander. Flex, as far as I'm aware, is fantastic. Sander hangs out in the Bevy Discord and is very, very knowledgeable. And they have pushed ECS in a direction that I don't think that many other people have. I have high respect for Flex. Would I recommend learning C nowadays? Only if you have to. You're saying because Rust isn't actually following Semver. It doesn't matter. It doesn't matter who's right in that situation, right? Like cargo, when you initiate a package, gives you 001. npm, when you initiate a package, gives you 1.0.0. And the way that those Semver packages actually resolve is different. Right? So, again, if Semver is so clear and so rule-based and so specific, why are there completely different implementations down to the ways the libraries are implemented? And the answer to that is it's not specific. And it's not as strict as you would like to imagine that it is. If a cargo's version resolution doesn't follow Semver, if the version is less than 1.0, yeah, there's a lot of like, what happens if a package is less than 1.0? There's a lot of thought in the community that Semver really only applies after you hit 1.0. Not just, not in Rust community specifically, but just in like engineering community at large. Like you're free to, who developed Semver? I actually don't remember who developed Semver. Somebody did. Probably on the page. Oh look, Semver has breaking changes. Semver, Tom Preston Warner, GitHub person, Tommel person. Somebody did. For real? You thought it saw from nowhere. Start your release at 0.1.0 and then increase the minor version for each subsequent release, which is not what npm does and not what cargo does. So nobody does this, for example. When do you release 1.0? When your software is being used in production, which is just like, okay, so if I write anything, it's 1.0. What do you mean, please stop reading the FAQ? This is the semantic versioning spec. What do you mean, stop reading? This is like the official website. You want me to click on 1.0 or 2.0? Like, I get that you feel very strongly about this, but in practice, it's human to human communication. It is not, there's no enforcement of Semver. Build subchains. We too be bike shedding. Yeah. And I'm not arguing against trying to adhere to Semver, just to be clear. But fundamentally, Semver is a method of communicating from human to human, because there is no automatic enforcement. I guess technically Elm tried to do automatic enforcement at one point, but like nobody else does. So where are we? We're build subchains. Subchains is going to be like, at some point, this is going to return a vec of like chain, which is going to be like build subchains for something, build subchains for something else. Right? So if we have one fork, we have two of these build subchains and then recursion at some point. Otherwise, this is like a single recursion. The what you call it? I'm laughing because I don't think this is going to get resolved over YouTube chat. I get that there are things written in the spec, but in practice, this is not a thing that is adhered to in any real way, right? It is like loosely adhered to at best in practice. Even if you think that the spec is perfectly accurate. Okay, so build subchains. This needs to return a vec of potentially vecs, right? And then for each of those subchains, we end up with more vecs. Lost my train of thought. So for every root, we have all the entities. I believe that both are inaccurate, Lond, just to be clear. The part where you're saying I didn't differentiate between whether I think the spec is inaccurate or people are inaccurate, I think both are. I think in practice, what people do matters more. But I don't think that the spec is perfectly accurate either. Or perfectly delineates real world evolution of software is kind of what I would say instead. Okay, so we end up with chains that we're building. I'm not going to go into the spec right now. I'm trying to do the IK stuff. All you will say is that humans are involved. You're very, very many people. Therefore, standards do change meaning depending on the person and how they interpret it. This convo as an example. Yeah, I mean, Semver has two major versions as well. So, like, you have to specify which version you're talking about in the first place. And not to put too fine of a point on it, but if Semver were perfectly specified, why does it have two versions? Right? If you think that Semver is perfectly accurate and models everything correctly, then why did it need an update? I think Semver used the wrong version and led to the dinosaurs' extinction. I'm a fan of the flying meatball that hit the Earth theory. Build subchains. I think everyone's chill here, Sarov. I don't think anything is actually raised. Okay, so we've got a root entity. We've got all of the entities that are in that chain. We need to iterate until we find a child that has two. For each iteration, we either have the ability to add to the current vec or create a new vec, or both, I guess. Add to the current vec and create a new vec. So theoretically, if we have a chain, then we have children. If those children exist, if those children don't exist, we need to end the iteration, which I will mark as a to-do for the moment. No children and iteration return back, right? So there's our like recursion end case. But we also have this chopping of the vecs that is kind of annoying that we're going to have to deal with. So we may end up doing this with a for loop and just pushing into some vecs. Macro rules. Yeah, I think even in cases where you can overload addition, that is not what LON means. If you're using C and you can overload the plus operator, just because you're using the plus operator doesn't mean you're doing addition. To do add to vec, continue iteration, right? Kiddos filter, starting with the same axioms, you derive at the same formulas, no matter what symbols you used. Yeah, I think that's two sides of the same coin, so to speak. If the only thing we disagree on is whether Semver is a perfectly accurate spec or not, I think we're doing pretty good. Kiddos filter, entities contains entity. This needs to be itered. So next entities, these are all of the entities that we need to handle next, but these are all the subnodes, right? Well, technically these aren't necessarily subnodes, are they? We already did the check for the hash set, right? No. So we actually can't do this check until after. If there are no children on the current processed entity, we can stop here. If we need to deal with this, then let me to do this so we don't get red squiggles. Talking about C++ reminds me I have an assignment to finish. Pad Thai is great. You more disagree on the idea that there's no way to actually handle everything properly. There is, but people not using it correctly are not the spec's problem. I think that is something that we differ on. I think if you write a spec that is insufficient, that the majority of implementers don't implement it correctly, then you have written a spec that is basically not reflective of real world use cases, right? You've written a spec that is somehow not modeling the world correctly. Viewing it as kind of like not the spec's problem is, I guess, fine if you can live with the concessions of the assumptions that the spec is making. And I think that's really what I'm getting at. Like the assumptions that the spec makes aren't sufficient for real world use cases. Pad Thai ingredients, spec of ingredients. So far, I've not seen an example where the spec is insufficient, only where people were misusing it. I'm not going to get into this one. I'm not going to go into the spec on stream because then we're just going to get into this like weird, like pointing things out in the spec, waiting for chat, pointing things out in the spec situation. And that's not a great place to be on stream. So I'm going to continue with the thing that I want to do, which is IK chains. Next entities.length equals 1. You have my Discord. You're actually curious what kind of situations are there. There's no way to follow the spec if you know of any. By the way, YouTube doesn't have a reply feature in chat. You can you just at them. You don't have like I don't think you have like a right click reply, but you can just at their name. I definitely don't disagree that when it comes to chat, Twitch has a better implementation. Next entities, kiddos, iter, filter. So this is all of the possible next entities that are actually in. Right, entities that are actually bones. Because again, we're iterating over children, so we need to make sure that we're not like picking up meshes and stuff here. Or if we do pick up meshes, that they are actually meshes on bones and not meshes like that are children of bones and things like that. So if we can get the root that we passed in and it has children, then we continue. If those children are 0 or 1, to do no children and iteration return back, right? These two cases are actually the same, but we calculate them at different times because we have to do this filter. I guess we could write this in a way that does like a children get, like map it or whatever, and then put these conditions in the same place, but that's for a refactor, I think. So if 0 or 1, we're kind of, well, if 0, we're done. If 1, then we add it to the vec and we continue our iteration. If more than 1, then we have to iterate over these And this could be any number of bones, which is kind of annoying. We do, this is a subnode here. Subbase, I guess is what they call it in the paper. This is a subbase. Because we have a subbase, we close the previous vec, open a new vec by recursing, right? On Android, you don't see autofill. Ingredients, vec, broccoli, cabbage, corn bits. We should make a new recipe. Next entities.iter. Close the previous, open a new by recursing. So this is I guess something that we could do is hold state outside of this loop and try to build this structure up here. And then we kind of get away from needing to return vex of vex of vex. Right, let chains equals vec. And we start off with just the empty vec, right? Or I guess, yes, we start off with the empty vec. So we're here, and we start off a new chain with the root. We check to see if it has children or whatever. So this is a loop inside of this function. It's a horrid way to write this, but it's fine. The only case that we will conceivably hit a node with no children is if we are at the end, in this case. Don't say Semper, we'll get derailed again. No, we're done with Semper chat for the moment. Children get root else. So this is always root, right? Or this is always end joint of a chain, of full chain, right? This is the last case, has no children. In which case we're kind of just done, and we do chains. I guess this has to be in our loop then, right? So we're doing like this loop. Use loops instead of repeating. What do you mean by loops instead of repeating? There's a couple of loops in here is the issue. So build subchains, we start with a root entity. We have a query for all the children, and we have our entities if we have children. So we kick off by starting, say, hey, we're going to start a new chain. It's this vec. This is going to be mutable because we're going to push into it. We're going to loop over the children here. I think that we need to We have two options here. We can either do this as recursion or not. We only have a single iteration to get to the next subnode. We will never split. So we can just do the loop directly here and then do another call for the next vec, which I think will be simpler. Right, so we get original root here with the value, and then both of these have to be included here. Why is this? Can we not dereference this? Oh no, because it's not a sorry. It's not a reference. So I'm going to clone it into this vec and then use it. I guess we could just get the end of this iter.last. So we really don't need root per se. And then this is chain.iter.last unwrap because we'll always have it. References, cool. So we'll just get the current kind of like next thing for the loop from that iterator instead of storing it extra. We'll do kiddos.iter.filter for the children. If we have next entities, or I guess if we don't have any next entities, then we are kind of done. And we need to push chain into chains. So chains dot that last mute might be the right. This is a vec, right? This is a vec of vecs. You want to play with Learn Rust again? Nice. Wait, it should have been fridge meals. Why do we not have last mute here? Am I going insane? I was already struggling before the Sember conversation, honestly. Rust, vec, last mute. Last mute is there. Why didn't it show up? Weird. This will always exist, so we can unwrap it. And then we want to append. I can never remember. Push is going to be back. Push, and this is going to be chain. Right? And our issue here is going to be something related to FABRIK, multiple end effectors, missing semicolon somewhere. Oh, right, because I made this an FN and it can't capture if it's an FN. So let build subchains equals this closure instead. And then we'll let it infer. $168. And build some chains is going to get called down here, but we'll comment it out for the moment. Okay. And this has an error that could be handled, I think. Wait, that's not what that is. What is that warning? Children transforms. Let me get rid of a bunch of these that are causing We're going to need those, but sometimes it's hard to read on the size that I bring this up to for stream. To do unreachable statement. Oh, right, because it's after to do. That was silly. Why did I even look at that? Right. If next entities is empty, we push the chain on. Chain probably moved there is my issue. Value borrowed after move. We want to loop over this. We want to get the end. We want to be able to do this. Get current root, we'll call this. Right. Even if we got clone this, it's the same thing. So chain gets brought in. Chain is mutable. We have a borrowed after move issue here. Known to myself, next time I want to be productive, don't open this stream. Oh no. Well, sorry about that. um, moved into the loop. We don't really need to move it. We do use it later, but I think we can break out and do this instead. Basically, we end up having chain. So if we break out of loop, then we end up adding chain, presumably, because we do need the mutable access there. We're not only distracting you, but also Chris. Somehow he's immune to it. I've got some experience streaming. I'll tell you, I was also, I woke up and I was like, this is not going to be a productive day. So I think that's just the vibe today, and that's fine. Sometimes it's just not the day, you know? Sometimes you need to go for a walk. I think we need this to be mute if we do it like this, right? And then entities is a hash set of entities, which can be a reference. And build subchains has to be mute because we're going to call it repeatedly. So we have our chain, we loop, we get the iter. Why is that think that it doesn't need the mute? Not yet implemented. Add to vec, continue iteration. Perfect. Our to-dos are working. I let so many warnings stick around here. Maybe I should have done this in a scratch buffer. IK bodies, iter tools, end effector, transforms, bone length, mute chain, remove this mute. Variable does not need to be mutable. Variable does not need to be mutable? Oh, chain doesn't need to be mutable. Okay, because we haven't pushed in. Sorry. I thought that was, anyway, I thought that was chains. Okay, so chain, iter, last, unwrap, clone. We are going to need to push into chain at some point here. So we are going to need to deal with that. If next entities is empty, then we break because we have no more children. So we're done. If it's 1, then we add that to chain. So we are going to need to like chain dot push. What is it? Current root? No. Chain dot push next entities 0 would be fine. Why is that warning me? Doesn't need to be mutable, yada yada. Oh, because I keep putting things after to do and then going, why is it warning me? It's because it's unreachable, Chris. It's because it's unreachable. Error report from Creative Cloud. Yeah, that sounds like Adobe. That seems exactly like what I would expect randomly from Adobe when I'm not using their software. Anyway, that's a good thing. I came here to look for some inspiration, motivation. Sweet. I hope you got inspired by the pad thai in the fridge. Okay, so we have a sub base if we have multiple children. If we have this chain push, then I think we continue, right? And current root is going to pull that off after we've pushed it, which is cool. This is a break. This is no children, end iteration, return back. So this is a break. Right? And then we have a subnode. So if we have a subnode, we need to, I think we need to just push nothing because we're already operating on it. The question is, do we track the subnodes as well? I don't think we need to. I think that in this case, we theoretically break and handle this outside. Right? So the chain gets pushed in no matter what. Then we have our sub base. Our sub base needs to be the start of both of the next 2 chains. So it'll be like this again, which means it'll be next entities. So we have to break with next entities. Is that correct? I guess break with an option of next entities, right? So this breaks with none because there's nothing. This breaks with none because there's nothing. And then this breaks with some next entities. Right, so next S Next entities. These are terrible variable names, and I need to refactor this, but it's fine. Next s equals loop over this. Push the chain on because we've finished a subchain, and then call build subchains for each root, right? So for child in next ES, we have to do this. And build subchains probably has an issue around being called like this. Not found in scope. Oh, calling itself. Fuck. Okay. I'll have to break this out into an actual function then. You'd probably prefer to do C any day compared to C++. I hear that from a decent amount of people who like C. People who I've seen who like C tend to like C over C++. I don't know how true that actually pans out to be, but I think that pans out over a decent amount of people. We don't do language war here stuff. I know you're not doing that there, but we don't do, you know, C is better than C++ or anything like that here. Okay, not found in the scope because we defined this to be itself. Originally, I had this as an FN, which made more sense. This was capturing chains, but we probably want to break this out into its own function and pass everything in. So let me do that. Think that is the right, yes. Cool. So these are no longer breaks. This is now, I guess, returns. Breaks out of the loop. Okay, no, we're good. Chains needs to get passed in then, which is going to be a little bit awkward, right? What do we use chains for here? We actually do last mute, so that's unfortunate. Mutability is annoying. Rust is amazing, but architecture support is a bit of an issue for embedded. It's definitely not as widely usable for, especially I've heard like ancient architectures, like old computers. Rust doesn't necessarily support that well. But my understanding is that modern platforms Rust does just fine on. I mean, ESP32, I think, supports Rust officially. Maybe that's just Ferris Systems and stuff, but PowerPC 32-bit Endian. What is there anything that's a PowerPC 32-bit? What was the supported in the latest kernel? Cool. That's not really what I'm looking for. Debian still supports PowerPC 32-bit. NXP. Gotcha. That's is that mainframes? NXP? Semiconductors. Now we're fully out of my range of knowledge here. Don't know anything about this company. Wasm can compile Rust into most any binary format and is pretty easy to cross-compile if needed. Wasm's great, yes. It works basically just the most common that are supported, which is understandable. Which embedded binary formats are you having trouble compiling to? I think we just mentioned PowerPC 32-bit Big Endian. Let's just... Oh, LLVM supports it. So is the issue that nobody's defined the... I'm going to call them bindings for lack of a better term. PowerPC 64-bit and PowerPC unknown. So presumably just not the 32-bit variants. What's the exact target triple? I don't know. They were saying PowerPC 32-bit Big Endian. PowerPC unknown Linux GNU SPE is a target for Linux on 32-bit PowerPC processors. PowerPC unknown Linux GNU. PowerPC unknown. PowerPC unknown Linux GNU, which isn't on this page. Might be the same thing. You learn how to do that stuff and make sure you can run Rust Doom on anything. There's a bunch more in tier 3. Is the tier 3 not in the sidebar? I thought this was tier 3. Platform support. I guess this isn't organized by tier. PowerPC unknown. FreeBSD, VxWorks, NetBSD, Linux Muscle. I still don't see the Linux GNU that they mentioned, but I guess that's this one just in a different flavor. The one that I would love to see progress a little bit more is this one. It's supported by LLVM, but not Rust's LLVM version or something like that. You wanted ARM V8A, non-EABA, but closest is V7A. Yeah. You never tried to update to a new kernel since you're basically a newbie and stuff? Yeah, fair. I want this one to progress, personally. This is my... that's on my future goals list. Okay. Let's see. Did I have enough brain power to finish this right now? I feel like I started out with half a tank and it's just been draining since then. I don't really want to do mutability, but since we have to cut these vex off, it feels a little bit weird. The recursion here is basically like each chunk of vex needs to be its own recursion step. So I think that if we return a vec of vex and then collect it, that could work. In which case we don't need mutable access to chains because we'll never push into it. And then we can return a vec of entity. This will be each individual chain up to the next subnode. Will that work? Target triple is PowerPC FSL Linux, apparently. Which I didn't see in that list. Maybe I skipped over it. We could just loop this as well and keep the list of the next entities to process. I want to keep more information in this iteration. But my brain isn't wrapping around it right now. Let me write it out. No, don't do that. Okay, so what I want to do is I want to end up with ideally a vec of entities, right? And I guess that's not strictly speaking true, because something else that would work is a hash map of entity to vec of entity, right? And then this is a hash map of all of the chains starting at one of the ends. That's a little awkward because we do need to iterate forwards and backwards. Name of the algorithm, FABRIK, forwards and backwards. I forget what the R is for. FABRIK. So when we go to fetch these chains later by entity, we would have to fetch them by the node in a certain direction, which is kind of annoying, actually. So really what I want here is a vec of vex so that we can take each of the steps and basically go from bottom to top and then top to bottom by iterating either in reverse or in regular iteration order over the vec, the outer vec. And then for each of the inner vecs, those can all be done in parallel because we know that they are siblings. So if we start at the root and we go down, we get one chain, right? We get one chain. Stop at subnode. Then it's subnode, A chain, and subnode, B chain, right? So this is our next like desired situation. So we stop at the subnode. The subnode is the new root. We iterate over that. We end up having two children to iterate down. we end up with 2 vecs, and each of those ends up with that like tree form. FSL is a company Freescale, now sold to NXP. I assume PowerPC unknown Linux would behave similarly to Linux unknown GNU for generic PCs. Lon says, yes, you'd want PowerPC unknown Linux. Rust has basically no triples which aren't unknown in the middle. Anyway, I gotta go. Cheers. Later on. I should wrap it up here too, even though we're not going to get to the end of this right now. Start at root, iterate down, one chain, stop at node. Then we have the sub node for the next root. We iterate down those chains. We end up with, in the other example, for example, like iterate down to the sub node. We get one sub node. This has forks. We end up with n sub nodes, or rather one sub node for each of these chains. And then we need to run n subnodes for each of those. So it's not even a binary recursion. It's like an arbitrarily wide recursion, which is a vec. More like unsafe PowerPC, unsafe Linux. Come on, brain. I think that what we end up at, what we end up at here is effectively we want to root node, sub node, right? We end up with a vec here. Actually, we end up with the vec of children, or the same size as children, right? So we end up with root node, sub node. Doesn't matter what order it is. Are you trying to escape from Vim using binding JK? Let it reiterate down. We get one chain, we stop the subnode. We end up with some state that is basically just the iteration of nodes that we need to process next. So we return the children, right? And then those subnodes have to iterate each. So we can do a for loop over this and build one chain for each. That gives us the full next chain starting points, all the subnodes in full number. And then we just iterate over that again, right? Stop at subnode. Then we get a vec of, well, I guess this one, in our case, currently, it is one subnode into two into no more. And technically speaking, this root, like this subbase up here could be the root. So if that's the case, then we immediately have two children. And this is basically becomes like a list of 1, 2, 3, 4, 5, 6. We'll call it like AA, BB, which is just kind of weird, but fine, I guess. So we can collapse that into the same array, or the same vec, and return a single vec, and then iterate over that again, which kind of flattens the whole recursion, which is what we need to do. But that puts us in a position where we need to like keep track of some of our state. You can't use VS Code Codium anymore. Can't use Rust Playground either. Tried to move around with Vim commands and just type JKLSC. Later, Robert. or later robot, I guess it's not Robert, robot JSORG. Right. So in pseudocode, we basically have let next nodes. This is our subnodes, which starts off with root, and let chains, which starts off with, I guess, nothing. And then for node in next nodes, this is just pseudocode, although it happens to be not yelling at me. For node and next nodes, we need to iterate chain. So I guess this is really like next nodes dot iter dot map node. Right? And this is iterate chain. This is also a little bit weird. This would return, this would probably be flat map, and it would return the next subnodes and whatnot. And that vec could probably be a hash set to collapse that structure too. We just need to draw a line between each of those subnodes and their children. Use navigation keys in Vim. Okay. I need water and lunch and to try to kickstart my brain. So I think I'm going to call it there. I might go early tomorrow. I might do an early stream tomorrow. Something like 6 to 9 my time or something like that. So I'll try to have this written for that stream. I think that's it for today. I need to take a walk and a nap is what I need to do. Get some food. So thanks for hanging out, everyone, and I will see you tomorrow.